Welcome to Math with Mrs. Seeley. Let's get started on this 2022 free response question number 5. It says to consider the differential equation dy dx equals 1/2 sine pi over 2x times the square root of y plus 7. Let y equals f of x be a particular solution to the differential equation with the initial condition f of 1 is equal to 2. It also tells us the function is defined for all real numbers. A part says a portion of the slope field for the differential equation is given below. Sketch the solution curve through the point 1, 2. Recall that a slope field is made up of these hash marks, where the slope of each one of these hash marks is the value of the derivative at that specific point, and it helps to determine the general shape of the solution curve. So if I'm going to draw through here, I'm going to follow the path. So I'm just going to kind of follow these curves. Follow the curves. Make sure you go through the point that they want you to. If you did this correctly, you're going to get the first of 9 points on this essay. When you're doing this, make sure that you follow the shape. Make sure too where those horizontal tangents are, that those are where your maxes and your mins occur. Make sure that you go through the point they told you to, and that you're kind of going to the edges of the graph. Another thing is they don't want us to go below the x-axis, stay above the x-axis. B part says to write the equation for the line tangent to the solution curve at that point. And after we do that, we're going to approximate point 8. Recall that if you're going to write the equation of a tangent line, you need your formula y minus y sub 1 equals x minus x sub 1. We know the point is 1, 2, which is going to be the xy that we're going to need in our formula. But the other thing we need is the slope. Now remember, slope is derivative of tangent line, and they gave us that right here. This is the derivative, so that's how you're going to get the slope for your line. We're going to plug our x and y values in. So to get that, it's going to be 1/2, and then it says the sine of pi over 2 times our x value, which is 1, times the square root of y, which we're going to put in a 2, plus 7. So that's 1/2 the sine of pi over 2 times the square root of 9. Now that's 1/2. Think about the sine of pi over 2. Use your unit circle. Pi over 2 is right there. That goes with the ordered pair 0, 1. You also know that sine is the y value, which in this case is 1. And the square root of 9 is 3. So I get 3/2 for my slope, or 1.5. So y minus y sub 1 equals your slope. I'm going to use the decimal, and then x minus 1. So then I will add this 2 over here and have y equals 1.5, x minus 1 plus 2. If you got the equation of that tangent line, give yourself another point. Now we're going to take that tangent line and use it to approximate f of point 8, which means you're going to take your point 8 and you're going to go put that in for x. So 1.5 is equal to 0.8 minus 1 plus 2. Now recall, question 5 is going to be one without a calculator. So 1.5, think right here, if you had 80 cents minus $1, that'd be negative 20 cents or negative 0.2. Let's multiply that. So that's going to be negative, and you're going to have 1.5 times 0.2. So if you multiply that, and then you're going to jump your decimal 2 places there. Sorry about that. And so you're going to get 0.30, but negative 0.30 plus 2, and you're going to get 1.7 for the value of f of 0.8. If you got that value, give yourself another point. C part. It says it's known that the second derivative is positive over this interval. So is that approximation that we just found in part B an overestimate or an underestimate? And then give a reason for our answer. All right, you know that if the second derivative is positive, that means that we are concave up. Just get a visual of that. Concave up would mean that the curve could hold water, so to speak. So those tangent lines, wherever they may be, they're going to be up underneath the curve. So the tangent lines lie beneath or under the curve. So if we're using something underneath as the approximation, that means that f of 0.8 is an underestimate. If you got that it was an underestimate with a reason, give yourself a point. One of the things that they're looking for is that you mention concave, that concave up, or that it's that. So look for that. All right, D part. Use separation of variables to find f of x, or y equals f of x, the particular solution. All right, so I'm going to rewrite this. But you guys know that whenever you're doing separation of variables, that's the first thing you do is you separate the variables. Get your x terms on one side and everything with the y term on the other. So the first thing we'll do is maybe multiply both sides by dx. So those cancel. And I have dy equals 1/2 the sine of pi over 2x, the square root of y plus 7 dx. Notice they're not separated yet because this term needs to be over here. So let's divide by the square root of y plus 7 to both sides. So if I do that, I'm going to have 1 over the square root of y plus 7 dy equals 1/2 the sine of pi over 2x dx. If you got your variables separated, give yourself a point. Now, you know the next thing we have to do is integrate. The first thing you do is separate your variables. The second thing you do is you integrate both sides. To integrate this side over here, actually both sides, we're going to need a u substitution. So I'm going to need a u substitution here. I'm going to let my u be y plus 7 so that du is equal to 1 dy. All right, let's substitute that back in. So that would be the integral of 1 over the square root of u du. If I rewrite that, isn't that really u to the negative 1/2 power? So I'm going to add 1 to it. So that's u to the 1/2, divide by 1/2, which means multiply by 2. Now go put your u back in, and we'll have 2, the square root of y plus 7. If you integrated that sign correctly, give yourself a point. Now let's integrate the other side. So over here, we're also going to need a u sub. So we're going to let our u be pi over 2x. Then du, or the derivative of u, is just going to be pi over 2 dx. All right, so let's go back. Now, I like to take my constants and put them out front. I just always do that. So I'm going to have 1/2 the integral of sine, but where that is, we're going to put a u, and then dx is, think about this, dx, which is what we want, is going to be 2 over pi du. I'm going to put my 2 over pi out front, du. So these will cancel, and I have 1 over pi, the integral of sine u du. But you guys know that the integral of sine u is negative cosine u plus your constant. Now go back in and put your u in, and you have negative 1 over pi, the cosine, but where my u is, we said right here that was equal to pi over 2x plus c. If you integrated this side of the equation correctly, give yourself another point. Now let's solve for the constant of integration. To solve for the constant of integration, we're going to come back up here and use the initial condition. This is our x, and this is our y. So we're going to come back down here, and we're going to say 2, but the square root, but where that y is, we're going to put in a 2 plus 7 equals negative 1 over pi. The cosine of pi over 2, but where my x is, I'm going to put a 1 plus c. So that's going to be the square root of 9, which is 3, but times 2 is 6. So 6 equals 1 over pi. The cosine of pi over 2. Okay, let's go back to our unit circle. Pi over 2 we said is up there, but this time we know that cosine is the x value. So all of this right here just turns into 0 plus c. So c is equal to 6. If you used your initial condition and you found your constant of integration, give yourself another point. So let's write the equation. So now we have, for our equation, we have 2, the square root of y plus 7 equals negative 1 over pi, cosine, parentheses, pi over 2x plus 6. Recall, and that's just right down here, it's just taking this at the bottom and just putting in our 6 on the end, that plus 6. All right, we have to solve it for y. So we need to start peeling things away. I'm going to divide every term by 2. I've got to be fair. What I do to one, I do to all. So that'll be the square root of y plus 7 equals, now right here, we're dividing by 2. Think of that as 2 over 1. So if I flip and multiply, doesn't that become 1 over 2? So that means I'm going to have negative 1 over 2 pi. The cosine of pi over 2x plus 6 divided by 2 is 3. All right, I'm trying to solve it for y, but he's trapped under this square root house. So we need to square both sides so that we can get him free from the square root house. That's just going to give me y plus 7. And I'm just going to say, you know what? We had to square this whole thing. Just don't even touch it. Just write it like it is. Quantity squared. I'm going to turn into brackets now. And then we're solving for y. So just simply subtract your 7. And you have y is equal to the square, or negative 1 over 2 pi. The cosine of pi over 2x plus 3, quantity squared, minus 7. If you were able to solve this for y, give yourself another point. Remember that each essay question is worth 9 points. I have those in red for you. Just an FYI, if you're curious, the mean score on this, when it was taken back in 2022, was 3.11 out of 9. I hope you found this helpful for your AP Calculus exam preparation. If you did, please consider liking, commenting, and subscribing to the channel. And be sure to check out other AP Calculus questions, explanations, as well as other calculus tutorial videos on the channel. See you next time.